Have you ever pondered the remarkable resemblances between mechanical and electrical systems? They might appear distinct, yet these two systems share intriguing commonalities that often go unnoticed. Welcome to a profound exploration of these surprising similarities, as we journey through the world of mechanical gears and electrical circuits, control mechanisms, feedback loops, and oscillations. Picture a gear system. Gears transfer mechanical energy between rotating shafts, a process that mirrors how electrical circuits transfer electrical energy between components. Envision a gear as a voltage source, while the smaller gears represent resistors and capacitors. Just as gears mesh together to transfer motion, these electrical components interact to control the flow of electricity. Efficiency is a crucial element in both systems. In the same way that friction in gears can cause energy loss, resistance in electrical circuits leads to power dissipation. The relationship between torque, angular velocity, and friction in mechanical systems is comparable to Ohm's law, which relates voltage, current, and resistance. It's all about maintaining balance and exerting control. Now, shift your thoughts to control mechanisms. In mechanical systems, motion is dictated by levers and switches, whereas in electrical systems, switches and relays regulate the flow of current. Whether it's maneuvering a lever to alter direction or toggling a switch to control a circuit, the same principle applies. Control over the system's behavior. Both mechanical and electrical systems employ feedback loops to sustain stability and achieve desired outcomes. Just as a thermostat regulates heating based on temperature feedback, electrical feedback loops manage voltage or current to maintain system equilibrium. Whether it's a flywheel stabilizing rotational speed or a PID controller maintaining voltage levels, feedback mechanisms play a pivotal role in system control and stability. Finally, consider oscillations. A mechanical pendulum swings back and forth while an electrical oscillator generates alternating currents or voltages. Whether it's the rhythmic motion of a pendulum or the oscillating voltage of an AC circuit, the fundamental principles of periodicity and resonance are universal. So, the next time you encounter a mechanical or electrical system, remember the surprising similarities that tie them together. From gears to circuits, levers to switches, the analogies are everywhere, waiting to be discovered. Thank you for joining this exploration of the interconnected worlds of mechanics and electronics. Don't forget to like, share, and subscribe for more captivating insights. Until we meet again, keep your curiosity alive.